So the first thing we want to do is we want to implement a hash function, which takes a certain amount of time to be executed, like SSH256. So I just double check whether I have provided this as a download link, otherwise we have to type it. That's something I have to avoid. But the hash function works as follows. So for each character in the string, it basically takes the ASCII code and then reapplies the hash function again with a substring where this character is removed. So it's a recursive function, just to generate some CPU cycles.
So you are creating your own hashing algorithm?
Yes, yeah, that's basically those 11 lines of code. And
then you are using this to calculate as the transaction.
Actually, yeah, that's here. Maybe I just. So that's basically the thing what also is done in Bitcoin. You have a while loop and you have a nonce, and then you hash. And in this case, because I'm calculating modulo 1, eventually you get 0. So eventually you will find a number which where this number is a divider, and then I break. So that's the proof of work. And now we need this knowledge of node web, so we create an endpoint which is called create transaction, so that actually pushes the work to the cloud. We could run this also on the local system. That's the transaction plus the nonce with a modular operation, and once we found it, we return the nonce we have found. So that you can see here. So here is the hashing algorithm, here is the proof of work, and here we just return the nonce, and also we return the cost of it. Just want to know how long it takes. Here's an example. So we can create a transaction, and the transaction can be an arbitrary string. Here I just transfer money from one address to another, and that's the amount. And then for that string, the nonce is calculated. And then I can run submit transaction, which runs the following code. Again, I have the hash function. And then it's an easy thing because I basically just use the transaction and the nonce, which I have found out. So that code is running in parallel on each peer. And if the result is 0, then I accept. So that operation has no cost at all because the hash function is only called once. But the create transaction is having a high cost. So it's expensive to create transaction and cheap to validate transaction. That's the property of a Byzantine fault tolerance consensus algorithm. Okay. So that basically means if the hash value is 0, the nonce is correct and we can accept, otherwise we reject. And then we have this flow here. If its status is accept, we add it to the blockchain, which is our NoSQL database, otherwise not. And I think it's nearly done. So what we have to do is we have to create some peer-to-peer simulation. So we have no discovery and dynamic network creation yet. We just, in a setup of multiple people participating, we just distribute the URL of the submit transaction endpoint to everybody, and we include it here. In this case, it's only 2 peers, and actually we can distribute transaction by calling the endpoint in parallel on every participating peer. And I've tried this already, and it works. So after that, we can put everything together with a little user interface where you can create a transaction at a nonce, submit it, and then you see that transaction on every peer in the NoSQL database. Okay, it was a thank you. Welcome. Okay. So now it's the question: shall I implement it, or is that sufficient?
I think it's
okay. What about you?
Yeah, actually, I think I will just watch a little bit, but then I will have to leave soon as well.
Okay.
So,